take a look at our second thing for the day, which is the distance formula. You guys don't need to write down this slide, but I would like you guys to watch. Once again, you notice I've added those little dotted lines here. So our goal is I want to find the distance. Now I've added the dotted lines for somewhat of a similar reason, but it also, you guys might notice, it makes a triangle, right? And what kind of a triangle do I have here? It's a right triangle because this is like a 90-degree angle here, isn't it? Now there's a rule about right triangles, a real famous one. There's a few of them, but does any come to mind? What is it? No? Well, I think I heard somebody say it. What rule do we know about right triangles? It's Pythagorean's theorem. Pythagorean's theorem. And that rule says that a squared plus b squared equals c squared. And that's where c is the hypotenuse. Which of these sides represents the hypotenuse? D would. So this is my hypotenuse. The other two sides are what we're going to call the legs of the triangle are the A and the B. Now, I'm going to go back and we're going to put the coordinates of this point on here again. What were the coordinates again? This point? How far over is it?
Oh, x1, y.
Other way. It's x2 over and y1 up. So, now here's the deal. This is a right triangle, so I can use Pythagorean's theorem. So, we got to find these lengths, though. I got to find out what A and B are if I want to do that, and we're going to use these coordinates again. So to find out what this distance is, we're going to find out how far away is x2 from x1. How can we find out a distance between 2 points on a number line? Like, what if I told you one point was at 5 and another point was at 12? What would you do to find the distance between them? No, you don't want to add them. You would subtract them. If one number's at 5, one's at 12, you'd subtract them. That'd tell you there's 7 numbers apart. So we're going to do the same thing here. You're going to take both your x values and you're going to subtract them to find out how long this segment is. So x2 minus x1, that's the A length. Now we're going to find the B length, and this time, how am I going to do that one? Yeah, you're going to subtract your y values. Okay, now what's the point of doing that? Well, we're going to use Pythagorean's theorem, but instead of a squared plus b squared equals c squared, we're going to use the lengths that we have on this triangle. First of all, a is what? What have I used to represent the length of a? x2 minus x1. So instead of a squared, we have x2 minus x1 squared, plus, what's b? y sub 2 minus y sub 1 squared. And then we have c. What letter am I using for the hypotenuse? We're going to use d for the distance, and it's c squared, so we have d squared. Now, I don't want to find out what d squared is. We're looking for the distance, or the length of that line, the black line here. So I don't want d squared, I just want d. So how can I get rid of that squared? You square root both sides. And when you square root both sides, the square root cancels out the square, and you get d equals this. And that should look familiar to you guys. You've probably seen it in geometry last year. So that's the distance formula. So you guys are going to copy it down and write down the title here. So we're going to use the distance formula to find out the length between 2 points on a coordinate plane here. So now let's go ahead and do these two problems. So go ahead and write down number 1. Here we go. When I do the distance formula, I personally prefer to start off with a blank template so I could just plug numbers into it. So, and what we plug in is the x's and the y's. So we're going to, now remember in the distance formula, to find the length of those sides of the triangle we're doing, we subtracted the x values and we subtracted the y values. We're not adding them, we're subtracting them. So what are my x values? 1 and 2. So we're going to subtract those. And then we have the y values. What are they? 3 and 5. We're going to subtract those also. And then at this point, it's really just a matter of, please excuse my dear Aunt Sally, PEMDAS, order of operations. So you would do your parentheses first. 1 minus 2 is a negative 1. 3 minus 5 is a negative 2. Square your negative 1 to get 1. Square the 2 to get 4. Then we can add, and we get 5. So the distance would be 5. And if you wanted to get a more comprehensible understanding of what that length is, if you use your calculator, you can just punch in the square root of 5 and you get about 2.2. That would be about the length of that line. Okay, go ahead and write down number 2, please. Number 2, same thing, but with this one, I think we should definitely be careful with our negatives because the formula has negatives in it also, and that can cause some issues, as you've seen before with formulas. So let's go. What are my x values, first of all? Okay, so we're going to have a negative 3 take away 4, right? And my, well, let me work through this here now. What are my y values? Now watch this carefully here. Ready? Negative 1 minus negative 2. Watch out for those double negatives, okay? The formula contributes a negative, and then we're plugging in a negative, which actually makes positive. So let's go ahead and work this out now, see what we get. Negative 3 take away 4 is what, guys? It's negative 7. If they're the same sign, you add it and keep the sign. If they're the same sign, you add it and keep the sign. That's kind of a rule I go by. And then here, notice they're opposites. You got a negative 1 and a positive 2. So they're opposite. So we subtract them and you take the sign of the bigger number. All right. So now we do our exponents and we get 49. 1 squared is 1. Add them together, get 50. And unlike the last problem, I'm not going to stop here because why? You can break down the 50. See, 5 was a prime number, and it didn't really break down into any pairs that we could take out. But we are going to have to simplify this square root. Something we did a little while ago. If we break apart our square root of 50, what makes 50? 25 times 2. And 25 breaks apart into 5 and 5, right? So really, instead of the square root of 50, we could think of this as the square root of 5 times 2. And if you guys remember our little story about the turtles, when a mommy turtle and a daddy turtle love each other very much, they have a baby turtle that looks just like them, and then they abandon them. And this turtle over here never got to have a baby because there was not a daddy turtle to go with it. So the answer is, in the end, 5 square root 2. That's for number 2.